Alright, so yesterday you guys learned to solve basic radical equations. So can you help me with this first one? We're going to solve for x, get x by itself. What should we do first?
Cube both sides.
I heard cube it. You always want to try to get your cube root by itself if there's only one, but this time there's two, so we really can't get it by itself. I mean, that one's already by itself, so you can be like, oh, that one's already isolated, like you guys saw yesterday, right? So I can just cube it to get rid of that one. If I cube one side, of course have to cube the other. Alright, then let's see what's left. Over here they cancel out. What happens on this side? Those cancel out, you get x. So is it 3x?
No.
That's the mistake I see tons of students make in radical equations, so don't make it. The 3 was inside the blue cubed thing, right? It was like part of the left-hand side, so cube it. It's supposed to be 27, right? And then you just have a little linear thing from Algebra 1 to solve. So solve for x. These and this and this are like terms, so I'm going to subtract 7x that way. I guess I'll show my work this time. Oh, so this is going to be nice. It's just going to be 20x equals 5, and then we can divide and get 5/20ths. That reduces, doesn't it? Yeah, a quarter. Cool. So there's our answer on that one. Now yesterday, you guys learned to watch out at this particular kind of equation. I think it's the second or third time this year where we've had a special kind of answer. What was that kind of answer?
Possible.
It's called an extraneous solution. Sometimes answers don't work. Now if you just get one, it's probably a fair bet that that's actually an answer. I'm not saying you have to check all of these, but if you get 2, you should be a little bit skeptical. It's of course possible to have 2 answers in these kinds of equations, but it's not very common, so you should be skeptical if you get 2. You don't have to check them every time. We'll just assume that that one works. Okay? So let's get that guy out of the way. Second one is an inequality, so I think this one is a pretty easy inequality though. The radical is already isolated, so I can just what to get rid of it? Square it. If it was 4th power, I'd like 4th power it on both sides, doesn't matter. So I have 2x minus 7, those cancel out, is greater than 81, and now I'm solving an inequality. It's just a nice easy linear inequality, right? If you were left with a quadratic inequality, what would you have to do? We learned how to do quadratic inequalities this year. You'd have to use a picture. You would have to use a picture. If it's not a linear inequality, you must use a picture. You'll be wrong almost every time. So I don't know if there's any of those in your assignment, but there certainly could be. So let's see. Add 7. You get 89. 88. I can't add. Thanks, Larry. And then you divide by 2, and you get, of course, 44. Okay. So if I have something that's an inequality, though, I should probably picture those solutions. There's more than one, right? In fact, 44 is not even one of them, is it? I just want things bigger than 44 strictly. So I should probably draw a little number line and go 0. Oh, I'm just going to pretend this is 44. Should I throw an open or closed circle at this one? Open circle. And should I be shading to the right or to the left? Everything bigger than 44 is this way, and my interval notation is then going to be parenthesis or bracket, parenthesis, 44, comma, all the way to infinity will count. So that's the set of solutions that will work. Anything that's in the red. Okay? So I guess I should have made this red. Got a question, Richard? Okay. All right, let's look at one that's a little bit more of Algebra 2, because those are kind of Algebra 1 level problems. This guide, step 1, is it isolated?
That side is.
The right side, the radical's isolated, so get rid of it. Again, remind me how? Square it. Does that mean I should like go like this? Squares don't work like that, do they? Powers don't work like that in general. You have to do the whole side. Because if you just did the pieces and like tried to distribute that, I don't think that distributes across plus. It does for a product and the quotient, but not a plus, right? I think that's true almost all the time this year. So this side it cancels, and that's nice. What happens on the left then?
X squared plus 4x plus 4.
Okay, Kyle told me this. Where's this coming from? Richard.
Basically, he's coming down to x plus 2 and then x plus 2.
Yeah, so Richard's saying you really have to think about this as the whole thing squared, which means the whole thing times itself. There's your x squared, there's your 4. This inside and that outside together give you your 4x. What's another way to get that 4x? Let's go back to the problem right here. Is that a Pascal triangle problem or not?
Yes.
Pascal's very useful for expanding binomials. So Pascal goes where? 1, 1, 1, 1, 2, 1. 1, 2, 1.
X.
Walk it down. Walk it up. Same answer. Okay? But somehow you should be expecting there to be more than just the first thing and the last thing squared. Okay? However you remember that is your choice. Alright, so we've got this little equation left. It's a parabola, isn't it? So I think we're probably going to want to try to factor or use the quadratic formula. Hopefully not. I don't want to. But, like terms? We got these guys. Which way you guys want to go? Which way, Bradley?
4 over 3.
You want to bring the 4 over here? Okay. Just follow Bradley. So then you're going to have x squared plus 4 equals negative 1x plus 6. Okay, then what do you want to move next then? Somebody else? Minus 4? Okay. See, at this point, because of the choice of moving stuff to the right instead of moving stuff to the left, I'm also going to have to move what to the right? The x squared. So I'm going to have to go like this. Because I need to set this thing to 0. And see, then I'm like, oh man, I have like a negative x squared now. Oh. So it probably would have been better to move stuff the other way. But it doesn't matter. I mean, this is still right. You can do algebra all kinds of different ways, except now,
Can you just multiply both sides by negative?
yeah, I think we're totally going to want to either factor out a negative 1 or scale it by negative 1. Nice. Let's do that, Josh. Josh says you're going to do that to fix that issue. Get rid of this stuff. So we have 0 still on the left. Now we have positive x squared like I was hoping for. The signs all switch on the right-hand side. And I think this one factors. We don't need our formula. I don't think I gave you any where you need your formula on this assignment, by the way. You shouldn't need the quadratic formula. Maybe I'm wrong, but I don't think so. What does that factor as? Plus 2 and minus 1. So our answers are negative 2 and 1. So I said you should be a little skeptical if you get 2 answers in radical equation land. One of them might not actually be true. It's kind of a byproduct of the solution process. If you guys know what I'm saying. The byproduct comes from squaring it at the beginning in this case. If you learn more about operator theory, you can see where byproducts sneak in all the time. Now, I'm not saying they both might be right. We should think how to decide if they're right. You could plug them back in. I hated that. I don't know if you guys are with me, but like when I took Algebra 2 and pre-calc and stuff, our teacher always said, plug in your answers every time. Make sure they're right. And I was like, no, teacher, I will not be doing that. I'm sorry. I'm just too lazy. I just don't care enough. So I was always searching for shortcuts. So I'm sympathize if you're that kind of person. I know none of you want to plug all your answers in all the time. You should just know a few places where you kind of need to watch out. This is one of them, okay? So I think you should go back to the very beginning, rid of all this extra stuff that we did to our pristine equation, put it back in its natural habitat, if you will. And just think about what the graph looks like. And then you also get practice with the graphs, which matters as well. So what does the left-hand side graph look like? This one. It's just mx plus b, right? So the y-intercept is
0, 2.
0, 2. And then the slope is up 1 over 1. Okay, so there's a sketch of x plus 2. And then I think last lesson we just learned how to graph this guy. So now the right-hand side, I think it has a couple transformations. Does it have a sneaky one? Two things inside. What do you have to do? Pull out the 3 factor. So you have x plus 2. So this is some kind of horizontal stretchy or compressy thing, right? But the main thing is that it's shifted 2 to the left, like you guys just practiced in your library activity, right? So 2 to the left. Oh man, this one's going to be subtle. Let's see, that was back 1, back 1. I think those intersect right there. So what do you guys think? If I go like this and draw my shape, does this problem look like it has 2 answers?
Yeah.
It does. This one, I don't think there's any byproduct, no extraneous solution, because that is the exact spot where they intersect. I just happened to get lucky on this one, you know what I'm saying? And then clearly they're going to intersect somewhere over here. Might it be 1? I think it might. So on this problem, it was just good enough with like the slope of that line and the setup of this red radical function for it to cross twice. But you can see most of the time if you do a line with that red shape, it's going to miss it entirely, or it's just going to like cross it in one spot. Only when you have it like just the right slope is it going to hit it twice. That's why it's rare to have 2 answers for these kind of problems. Okay? So there you go. Let's look at one application before we leave off today. And I thought we'd do one that relates to the big extra credit assignment of the semester, which I think is only 5 problems. It's just like one of those, so it ought to be useful to you if you want to attempt that later. So we're of course going to watch a film about Einstein and some various scientists that eventually helped him develop the theory of relativity. So this problem deals with one little aspect of relativity. Why are we going to watch that soon? Because it has radicals in it. And because we get to learn some science, which is pretty interesting. So one side effect of Einstein's theory of relativity, developed about 1905, is that the mass of an object changes, in fact, increases if you go really fast. Now, how fast is really fast? I mean really, really fast. Like spaceship level of fast, or at least airplane level of fast, you know what I mean? It actually happens as well for like really small masses, but the change is so minute that nobody ever detects it, you know what I mean? It's like you get on a really fast car and you notice that you're getting heavier. You might notice a little bit though, but I think that it's not going to be too much. But if you were going really, really fast, your mass actually starts to change dramatically. So this is the equation that Einstein developed after all of his hard work, just one of the equations of relativity. So let me interpret it for you. So the effective mass, or the mass due to a velocity, due to moving fast, is equal to the rest mass, like the normal one, you know, the one you're standing still, and it's divided by this radical. So that's why I'm bringing this up now. So it's divided by the square root of 1 minus how fast you're going, the velocity, and what is this c thing? C is the speed of light, so it's just a constant. And of course your rest mass is also going to be a constant, like 100 pounds if you're measuring a person or something like that. But this is always going to be a constant too. We usually call it 3 times 10 to the 8th. And if you do the extra credit, you'll be working with that 3 times 10 to the 8th. But we'll talk about that in a couple weeks. All right, so this problem says, what do they want us to do? They want us to solve for the velocity, find out how fast we have to be going. If we want our effective mass, in other words, the real mass, to be doubled, how fast would we have to be going if we wanted to double our weight? Now, you weight-conscious people, I'm not trying to double your weight here, okay? But how fast would we have to be going? What do you guys think? Kind of fast, really, really fast? Probably like really, really fast, because otherwise you'd like get out of a really fast car and have to go on a diet, right? So, you guys are a tough crowd sometimes. Okay, so what does that mean? What should I like plug in? There's something to like plug in there. Any of your problems in this assignment, like you should be able to like plug something in. What does it mean? Double what? What do I want to double?
The weight, the mass.
So what? I should say 2 times what then?
The rest.
The rest mass, which was what? M sub 0. So I want 2m sub 0, and I want to put that where? I want that to be what the effective mass is. So that's what I'm going to do, and then I'm going to solve. Okay? So 2m sub 0 equals m sub 0 over square root of 1 minus v squared over c squared. They want us to solve for the velocity. So in science, you should be being taught to search for the question right away, and that's what I'm doing a little bit this year as well. They want to know what is the velocity, so I should be solving for v here. If you're a little bit confused and you're like, whoa, there's like all kinds of different letters in this problem, dude. Remember, these ones are constants. They're things just like when we worked with logarithms, like the logarithm of 2, and it's just some number. These are just some number. I don't care what they are. They're just constants. What's the only variable in that problem? V. And that's the one we're trying to solve for. Okay? So what should I do first? You guys got to help me with this guy. It's a little bit more involved equation, but not very much. Something we could do right away to get rid of one of those ugly constants. Bradley? Oh, we could do, what do you mean do the square root? Because you can't like break the square root up across a subtraction. Not allowed. You could multiply it to the other side. I like that. You could go like square root thing here and it would cancel out. Square root thing there. Multiply it on both sides. I'm not going to draw it because then it's going to get messy. But I'm going to have that times 2m sub 0 equals, it's going to cancel out here, m sub 0. Nice, good choice. Now at least v is kind of like more on the top. Yeah, you don't have to deal with the fraction part. Next part, how can I get rid of something? Get rid of something oh so easy. We're going to square the square root, yes, but I want to get rid of something first, just so it doesn't get uglier, Richard. Do you want to divide by 2? But do you want to divide by m sub 0? Because isn't it just going to go away then? Since it's on both sides? Yeah, it's just like gone. Okay, that's nice. So then we've got this left. I'm going to put the 2 out here. M sub 0 over m sub 0 is 1, right? Now, maybe I should divide by 2. I think we've got a choice. Do you want to divide by 2 or do you want to do what Richard said and square it? Didn't we just like square it when we saw that problem a second ago? I think so. Let's just square it. And 1 squared is pretty harmless. It's just 1. This is now quattro. Squared does what to square root? That was the point. It cancels it. Why'd I leave the parentheses? Yeah, because it's 2 all of that stuff, so now it's 4 all of that stuff. So now I probably want to go like 4 all of that stuff. So now I've got 4 minus 4 v squared over c squared. We're getting pretty close, I think, here. So, you guys tell me what to do next. Subtract 4. Remember, algebra is very easy if you fail to be intimidated and you have a little experience. One minus 3. Yeah, okay. Now what? Trying to whittle it away, right? And just get at that v eventually. Divide by this, right? So you get v squared over c squared equals 3/4. We're so close. V's almost by itself. What's in the way right now? C squared. C squared. Oh, it was just a number. It's how fast light goes. So if you want to get rid of it, if this said divided by 8, how would you get rid of divided by 8? You'd multiply by 8. So multiply by it. And the last thing you need to do, square root. Now technically, plus or minus happens right here. Does minus make sense though for velocities? You can go backwards, but I think we're just going to think about going forwards in this problem. So it kind of makes sense. So this is v equals square root of 3 is square root of 3. Square root of 4 is, there's no plus or minus in here, right? I can do all the square roots piece by piece. 2, square root of c squared, c. Now, that's the answer. Let's interpret it in a way that makes sense. Can you guys use your calculator and tell me what is the square root of 3 over 2? I think it's like 1.8. No, it's got to be like, yeah, it's got to be like 0.7, 0.8, 0.66, 0.866. That sounds right. Let's remember. Let's go back and interpret. So on the few problems that you have, the application problems, I want you to go back and interpret, not for math class, so you can function later, so that you have a chance to take things like AP statistics and stuff like that. You have to be able to function and interpret and read and think. It's not just the math. The math's the easy part. So, the velocity of an object, in order to get double the mass, right? How fast do you have to go? That says it. 0.866 c. What's that mean?
0.866 times the speed.
Exactly. So I'm going to say that in a sentence. I need to go 86%
Of the speed of light.
the speed of light to double my weight.
So that's not even the light.
It's pretty fast though, man. 86% the speed of light. C is really fast. I think C actually, by the way, stands for celeritas. It's the Latin word for swiftness, because light is the most swift you can possibly be. I'll see you next time.